Hey guys, it's MJ, the student actuary, and in this video I want to show you a little side project that I've been working on. Basically, it's a start to artificial intelligence. And what I've done is I've started off very simply by trying to make a AI that can beat me in the game of rock, paper, scissors. So let's go open up the app and then I'm going to talk through the code and how I did it. So as you can see, the graphic design is absolutely beautiful. It's absolutely gorgeous. Okay, anyway, jokes aside, let's get into it. So basically with the game, rock, paper, scissors, rock beats scissors, scissors beats paper, paper beats rock. Okay, we all know the rules. Let's say, for example, I choose rock. Okay, it will come, it says the AI beat me and it's got 1 point because the AI chose to go paper. Now the very first play we do is random. These things here show the probability distribution that the AI is going to be choosing. And as we can see, right in the beginning, it's 33% basically for each of them. What this is doing over here at the bottom is it's recording my pattern, and this is going to be very important when it comes to changing its decisions. So because I lost with rock, okay, I don't want to do rock again because I want to change to paper. So go to paper, and there we go, I won. So now I've won with paper, and you can see the stats. It still doesn't have enough information of my gameplay to change the stats, but we can see that when I alternate and I win, I got 1 point. So because I like paper, I'm going to go paper again. Okay, ooh, look at that. Now, because I've chosen paper twice in a row, okay, so I won because the AI chose rock, I've got 2 points. This is where things start getting interesting. So by alternating my win, I've got another point, and look how the odds have changed. So now the AI is thinking that I'm going to go paper again, and you can see scissors has increased the weighting of the probability there. So if I go paper again, oh, look at that, I lost, and scissors came in. Then it adjusts, and you can see this is what the probability distribution is showing. So that's kind of the game, and I mean, let's go look into the code to see how exactly I did it. How did I make this clever little program to beat me at Ching Chong Cha? Or that's what we call it here in South Africa, Ching Chong Cha, but I think rock, paper, scissors is the more correct name. Okay, so let's check it out. What I do is I start off with my weights. These are my variables. Oh, I must just confess, I'm not a programmer, so my code is going to be a little bit messy. It's not in nice method, so I do apologize for that. Programming is just something I'm trying to learn on the side because to me it's almost as important as reading as writing in tomorrow's world. So I highly encourage everyone to learn how to program. Anyway, these are my weights. The chance it'll be paper, the chance it'll be rock, and then scissors will be the subtraction of those two. Then I've given my AI a whole bunch of variables for it to think. So it's going to count whether I'm winning. So when I play the game, certain things can happen. If I win, do I repeat my style? Or when I win, do I alternate? Or when I lose, do I repeat my style? Or when I lose, do I change my style? And different players can have different combinations. You might play so that when you win, you play the same thing again, or somebody else might have it so when they lose, they alternate. So every person will have their own unique strategy, and my AI will try to figure it out what it is. My AI also has its own little personality in the fact that it has this confidence variable and this forget limit. I've set it to 5 and 3. I mean, I could extend this program to make it so that this confidence and this forget limit are random variables. And then what the AI will do is it will play against multiple people, and it will see at what confidence and at what forget limit did it perform optimally, and then it will set that. But it will first randomly choose and determine. So that is something that I could develop it further. Then there's the actual game choices, what it actually chooses, how it calculates the result and all that. And then I do give it a little bit of memory because what I'm doing is I'm looking at not only your current play but also your previous one to make a bit of a pattern. I could extend this AI to make it even look at the past, so it looks at your first play, your second play, and then your current play to even make it even more complicated. But remember, this is just a beginning introduction to AI. I'm doing this just as a little side project. So yeah, it's not for work or anything. So I'm just having fun with it. Okay, so what will happen is if you push that rock button, this is what happens. Okay, it counts that you did rock. Not that I'm using this at the moment, but it's just a nice thing to keep track of. The user chooses rock. Then we generate a random number between 0 and 100. And then if this random number is less than the paper chance, the AI will have chosen paper. And basically what we're going to be doing is adjusting these guys over here, the weights there. You can see that if the AI wins, its confidence grows by 1, and we're going to see where confidence comes in, and the score goes up by 1. Then we're also going to record how, what type of player you are. Are you a repeating player or are you an alternating player? It starts picking that up. Then what we do over here is we now look at if the random variable was greater than, let's say it was a greater number, it then looks, is it above paper chance and rock chance? And then if it is within this number, then the AI has chosen rock, and rock on rock is a draw. And then it does the whole calculation of repeating the style for draw or the alternating style draw, depending on what the history was. So the first time you play the game, there's no history, so the code will just skip this. And then again with scissors, you can see scissors, it loses, so the confidence gets reduced. And then yeah, same thing happens again. So you can see my code is a little bit messy. I should maybe have methods to make it more streamlined, but I was just interested in getting this thing done. Then, so it either determines whether it does rock, paper, or scissors, and then it adjusts the strategy. So if I lost, it will look at if my alternate style is greater than my repeat style for losing, it will adjust the probability. So here, let's say I chose rock, and my alternate style, or my history, it takes that into consideration, and here we see confidence is how much we're actually decreasing the chance by. So if the AI is very confident of how it's playing, then this change will be quite drastic. It might be 10% or something like that. If the AI is, it starts losing, we can see the confidence decreases, and then it's not going to be making as wild changes like this. So the worst case scenario is that my AI reverts back to 33% for rock, paper, and scissors, so that you can only beat it then by luck. You can't outsmart my AI. So if you are figuring it out, it will go back to that defense. But the whole idea here is that, I mean, if I keep going rock and I keep losing, it's going to change the weights so that it can predict what I'm going to do next. This does get a little bit complicated. I mean, knowing which one to change by which one else. Let me just try think it through. So, for example, what this is saying is that, let's say I lost. Okay, and this is where it gets confusing because you have to think, I lost, but the AI won. So when the AI wins, how does it change its game? Okay, so let's say, let's see what we can do here. So this is with rock, okay? So I chose rock and I lost, which means the computer chose paper, okay? If I, let's say I'm repeating myself. So let's say I did rock and I lost. So let's look at this here. So if I chose rock, I lost, and I played rock again. Then my repeating style, or my game style, is that I repeat the same move when I lose, which means the AI is going to adjust. It's going to increase for rock, and it's going to increase for paper. And then what this does, because it doesn't want to go scissors, because if I'm going rock, 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 it doesn't want to go scissors, so it will increase rock a bit, and it will increase paper by more, because that's for the win, and that's for a draw. It wants to avoid the loss. And then it will do the opposite if I'm alternating. So it does get a little bit confusing. And then I come, and then each button ends off by displaying the score, and I was just displaying, I think when I actually make the actual game, I'm not going to show people what the AI's brain is thinking, because then you can also beat it like that. People must play the game and be like, oh, this AI, how's it doing it? It's really cool. What I also do is I like to make the AI forget. So let's say you go paper, 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 and you build up a whole series or something, then the AI is going to be, oh, you're always repeating. And then suddenly you change your style and you're going to start beating the AI. So what it does is that if the alternate style win is greater than the repeat style win plus this forgetting limit, it will reduce. So it will kind of forget, so that if a player changes their strategy, the AI can adapt quickly towards that. And then what I also do is, this is not a very neat way, but just I want to keep the weights in balance. So I don't want it to be, like 100% that it always goes paper. I want to keep it so that there is that random element to it, so that when you're playing against this AI, there still is a little bit of luck involved. And then also this causes a lot of bugs. Is what happened was my confidence would go negative and then it would absolutely screw up everything. So I've just made a little if statement that if the confidence goes below 1, just put it back to 2, so that it doesn't go absolutely haywire, because then the opposite stuff started happening. That was a big scratch, brain scratch, but we finally figured that out. And then it records your history, and this was also just a little bit of diagnostics to show me what was going on while I was busy programming it. And then you can see I haven't been very tidy. It's basically the same thing when you do choose paper, just all the things are a little bit different. And the same happens with scissors as well. And yes, I know good programming conventions would be to put all of these stuff in a method and then just call that method. But yeah, I made this. It didn't take that long to make. It took a little bit longer to debug and make sure that it performed properly. But at the end of the day, that is my first little artificial intelligence in making a game. The dream is now to make it for the American football game, which is going to be a lot more complicated. But I think this is the first step in trying to take a player's behavior, figure out what he's going to do next, and not be deterministic by saying, oh, he went rock, we're definitely going to go paper next time. My philosophy is that an AI or information or knowledge, it's probabilities. And so instead of saying, okay, we're definitely going to go paper next, just increase the likelihood of going paper, because we know humans do have a little bit of that irrational factor. The person might just suddenly change their mind, and you do want a probability nature to incorporate that. And yeah, that is my little artificial intelligence. If you have any questions, feel free to pop them in the comment section. If you have any advice for me, please let me know. Like I say, I am brand new to machine learning and AI, so I am willing to learn. So if you have any suggestions, please let me know. And yeah, thanks guys for watching. Christmas is coming up, and then I'm going to start making some more actuarial science videos. Thanks for watching. Cheers.